Hello, many of you may have come across one of these before. It's a Megger BM6. Here we are. This is an insulation tester. This was left to me, and the person who had it before me didn't take the batteries out, and then I also forgot about it. If I can just liberate this from its case. There we go. One of the problems with these lovely instruments, one of the problems, if I can get it open, is the battery terminals corrode. Now, as you can see in this one, they're all nice and shiny and new. So what I thought I'd do is cover this, the operation of replacing what wasn't shiny and new to start with. I think that's a pokey feature on the bottom of there that it's the first time ever I've just fallen foul of that one. There we go, that's clipped in now. So there's the meter all repaired, and the thing I probably want to talk about is let's get this put away again. I don't want to lose any of the bits. Is how I went about replacing these terminals. Now we'll look at a couple of exhibits here. Here is the first one we're looking at. We can see that after I've cleaned off some of the corrosion, we've got just bare copper left there now, copper plate. Here's another one that hasn't fared quite so well. You can see that we've actually lost one of the terminals. Doesn't look too healthy, this one. We've also got some verdigris from the batteries that have leaked over time. Here's another one that's got some corrosion on it. Yeah, it's pretty much the same sort of story as a couple of them were okay. I mean, this was one of the terminals that was fine. And if we look at this, we're looking at a material that's, if I get it right, I think it's round about 0.25. So that's 1/4 of a millimetre thick, and it's a bit springy, but still got a bit of life in it, that one perhaps. Originally I was just going to replace the ones that were in poor shape, but you can see that there are some here. I mean, that doesn't look like it's ever been used at all. It's just a shame that some of the batteries have leaked and finished off some of these other terminals. So I did buy in some material. Here we have it. This is 0.5 millimeters. I guess the dimension doesn't really matter because we're cutting that up into small little bits. So first things first is looking at what it is we need to make. I mean, if you look at this one, I think there were 5 of this type in there, and 2 of this type. Now the difference between this one and this one is this, effectively that's far further over there, that's effectively like a half of one of these terminals. So effectively I had to make five of these and 2 halves. Originally I thought these were mirrored, but they're not. As they actually come out of the unit, they are both Oh, so that's one I've made. The other one was broken, but they're both both in the same plane. As you can see, when I did that, that was the one I think I made. No, I made that one right. Oh well, talking rubbish. There we go. So these are the pits we had to make, and looking at the form of this, you can see we've got effectively a U shape, flat, and an angle. So I thought the best way to deal with this was to make a former. So this is what I've got here. You can see that on this edge we've got a recess that's the thickness of the material. This is the new material. This was what was it originally? 3/4 brass. I've used brass because it's quite soft, and I ran this in the mill. So this edge here, if we put that bit in there, was 3/8. This distance I wasn't sure of because we had the curve, and I was too lazy to work it out. So what I did is I made a piece that was going to fit in, hammer it into the groove using this 10 millimeters former. So that would go into there. I then hammer that down into shape, and then I trim off so that it actually fitted the shape and gave me this kind of finish. And then I straightened it out, measured it again. So there we are. So we're around about 13, just under 13 millimeters there, and I think that's our bit over 3/8 on that one. This was just an end mill run down the cut, this one, and I looked at taking off to the new thickness, so that's a 0.5 mil recess, slightly less because I wanted it for the new part to sit slightly proud. So when I offered it up into the vise like that, where I clamped across these two surfaces, that one won't do it, but there'll be a new one with the slightly thicker material that would. So that was the idea, that when I clamped that in the vise, that would actually hold in place, and then I could form the rest of it over that edge. So that would put my right angle in to start with. Keep losing the bits. There he is. All right, okay. So that would go in there. Obviously this would be a flat piece of metal. Then I'd bend that over using my new favourite tool, a bossing mallet. So bash that over into the shape, and then use the former in the metal, on the metal, just to form that shape. I mean, this channel here was made with a 1/2-inch ball-nosed slot drill that I ran down there, and I just machined this out so that the profile actually fitted this one. As you can see, that is quite a tidy fit on there. So that was my pattern. The other feature I had on this one was to actually drill a hole. Here I didn't use a cutout because I haven't got a stamping tool. So what I did there is I drilled a 1/4 inch, which is the distance between these two parts, and measured in, what was the distance? 0.31 of an inch. So if we look at our development now, I should now do a sketch of this. Here is obviously a development that didn't go too well because we've got a bit of difference between the two gaps, but for this particular meter we're looking at 0.875 of an inch, and that's that square along this edge and this edge, and obviously these are all 90 degrees. So first part is to draw a centre line down through here, and then our first hole is 0.125 inches up. So then we put our centre mark in there, and that hole was, switching between metric and imperial again, 2.5 millimeters diameter. The hole for this one was 0.31 from the top edge, 0.311, and that was a 1/4 inch hole, which once I drilled, I then tin snipped here and here. So this would give us this development shape of this hole here. This is actually for the fixing screw, and this one is to give us the two halves of independent spring. I think if those two were bridged, because I've gone up to a slightly thicker material of 0.5 millimeters, I really would have been in trouble with that, in the fact that one would have made contact and dominated and the other one wouldn't, with the spring force of the batteries pushing up and not necessarily making even contact. You can see that this one we've got a fair degree of independent movement. Now I'm hoping with the thicker material that will be okay. So this shape, or our development as we call it, would then fit in here. We then clamp it in the vise, making sure that that's seated. Bend this section over. In fact, I'll go and do that just to show you off camera. So this is just going in an engineer's vise, and as the parts are brass and they're compressing, I'm going to make sure that I do nip it up fairly tight, because I don't want the part to actually slip in the vise. So now I'm just tightening that up. Just making sure that that's seated, and then so there we are. I've hammered that over now, so we're usually just given enough hammer so that you can start to see the imprint of that second edge. And now the next bit we're going to do is to actually put that part in there and hammer down to put our curve in. So I'll just go and do that off camera, and I'll be back in a few moments. So again, that's going in the vise. Make sure that that's nipped up. So what I've done is I've rolled the former a little bit in the gap here. So what I've done is again, I've used the bossing mallet because I seem to quite like that. The knurling on there is for no particular reason. This was just a piece of scrap of 10 mil. So hammer down just to take the main depression and the shape, and then hammer that way, hammer this way, to make sure that we do actually fill out the groove. I think that needs another bit of fitting on that one, but it gives you the idea. And then you can see we've got the my new shape with the curve in it, just because that's easy. As I said, if I had a jig I'd been able to do that one, or a stamp, but there we go. To make the other sections, these ones, it was effectively making one development. Let's find the development again, which I've gone and buried, have I not? No, I'm being silly. That is the development there, isn't it? I ruined it. Anyhow, when this was drawn out and drilled, all I had to do was carry this line down. Not sure how well that shows up. Like that, and then I'd actually cut down there, cut across here, and then just dress that end up with a light file, and then that would definitely be that particular shape, which would fit in on one side and also on the other, because they weren't handed. So there's the details of my terminals. Hope you enjoyed watching the video, and please watch my other videos. Thank you.